Good evening, everybody. Thank you for being here. I'm very excited to present our first series of tech talks. So they're actually intended to be broad topics around technology. Tonight we're going to talk about education. And Natalia, you have to... if you want to tweet tonight, you can use this hashtag. You don't have to spell Schibsted because it's a bit hard, but you need to remember the first three letters, SCH Tech Talks, and you can also use diversity in tech if you want. Yes. So my name is Sandra Garcia, by the way. I'm a data scientist at Schibsted. And I joined the company 2 years ago, which basically was a moment where the company started to transform itself. So Schibsted is a media company, for those that don't know. It's a company about newspapers and marketplaces. In Spain, there is Vivo, Fotocasa, InfoJobs, and so on. And in the last years, they've been experiencing a transformation from media to technology. And this means we've been doing a lot of hiring of technical profiles. And we're still hiring, and this is a very hard process. It's very hard to find good talent because there is a lack of engineers. There's still not enough people to fill all the engineering jobs that we need in Schibsted and in all the tech companies. I forgot what I was going to say next. No, so this is the problem right now. We have a lack of people that are interested, and this demand in technology will even increase in the future. And the education nowadays doesn't match this demand. So technology is still not present enough in schools. It's not taught properly. There's not many schools that are teaching programming to kids, or if it's done at a very late stage, maybe when they're in high school, when they've decided what they want to do with it, oops, can you hear me? Yeah. So yeah, it's important to start teaching kids about technology at an earlier age. Schools, they teach about astronomy to kids, they teach them about drawing, and it's not just because we want them to become NASA astronauts or famous painters. It's because it awakens certain skills like curiosity or creativity. So why not do courses that teach kids to solve problems? And programming is the perfect example of a tool that allows kids to do that. But again, this is still not done. So there's a lot of people that have started solving this problem on their own. Here are some examples of people that are deciding to bring technology to kids. So these are our speakers tonight. We have Linda Lucas, who is going to talk about her journey teaching, bringing programming to kids. She's going to talk about her book she's written about teaching kids to program in a fun way. Then we're going to also have CodeLearn, who is a school. It's a Catalan company that started in 2013, and now they have 9 schools already, and they're doing courses for kids, and also bringing technology like in the form of approaching them to virtual reality and teaching them how to use 3D printers. So it's very cool. And finally, I'm very happy to say Girls in Lab are also here. This is very cool because there's still this big lack of diversity in technology, which also includes the lack of women. This is a big problem because if we want to fill jobs and we're losing 50% of the population, we're screwed. So basically, they're doing a great job to bring also technology to girls. Yes, so let's start with Linda. Linda, she's done a lot of great things. She wrote this book, Hello Ruby, that teaches the concepts of programming to kids in a fun way. She also she co-founded Rails Girls, that teaches girls how to program in Ruby. And now this has a lot of, how it's called? In different cities you have Ruby Girls. And she also got a Ruby Hero Award, which you get if you really, you did a great job in the Ruby community, so that's also good. But I think the cool thing about Linda is that she's not just a programmer, she's an illustrator, and she's also a writer. I think this is very nice. She has a nice set of skills, and I think this is what education should be doing, should be teaching kids to have a nice set of skills that they've discovered they're good at. So we need to give them the tools to discover what skills they're good at. So I will stop talking, and I will let Linda talk.
it in the...
Yeah.
somewhere there. I'll try not... No, I'll just not jump around too much. Yeah, perfect. Okay. Perfect. I got a nice introduction now. My name is Linda. I'm an illustrator, programmer, a pretty mediocre programmer still, an author and a business school dropout. And I've marked all of the other identities in parentheses because that's how I feel. I still feel like I'm not 100% sure if I'm allowed to call myself an author or an illustrator. The only thing I'm really, really certain about is that I never graduated from business school. But that's the thing about us humans. We are not binary. Computers are binary. They can be one thing or the other, but we humans, we contain multitudes. And as mentioned, I'm the co-founder of Railscales, and I worked at Codecademy in New York for a few years when it was a little bit younger as a company. I was the 5th employee in the company. Both of my bosses were 22-year-old guys. We had a little bit less than 1 million users at the time, and roughly 10 million dollars of funding raised around the time. This was 2013, and I was there for 1.5 years, and our user base grew to 24 million users. Our bank account diminished, and everything that can break in a company of 5 people did break, and the processes and the people and the product. But it ended up being one of the best learning experiences in my life. Also, my bosses ended up being 23 by the time I left the company. And I felt that, oh wow, this is very important and very fun, but I also got a little bit disillusioned with the startup world. The idea that the best way to save the world is by making a dating app or food delivery service or something like that. And I started to really think how I want to spend my time. And I figured the most scalable change happens when you're 6 years old. And if we can really change the way kids see the world, we will have a different kind of a world. And that's the point when I decided I want to spend all of my time working with kids and become a children's book author. On this journey, I think the most important literature I've read comes from Lewis Carroll of Alice in Wonderland. And his ability to combine logic and magic is something that has guided me a lot in my journey. And in Lewis's words, if you're not really certain where you're going, it doesn't really matter which road you take. And keeping that in mind, I've kind of chosen 4 lessons learned from Alice and 4 lessons learned from being a children's book author for coding, and hopefully we'll be able to illustrate a few stories for you. But in order to get started with this story, we need to start from where all great stories in life start from, and that is from love. And in my case, the love was when I was 13 years old, and this was 2001. And I had this mad, crazy teenage girl crush on the Vice President of the United States, Mr. Al Gore. And unlike other teenage girls, it wasn't enough for me to make a scrapbook and collect like pages of him and so forth and so forth. I needed to do something bigger. And at the time, there was no Tumblr or Facebook or Pinterest. And I needed to learn to code in order to express all of my enthusiasm and excitement. So I learned HTML and CSS and how PHP works and how to set up a server. And this, ladies and gentlemen, this is the first and the last Finnish Al Gore website. And I was so excited. I felt, wow, like I can make things with words. I can create something out of nothing with my own ability to create. And I felt, wow, technology is amazing. It's so much fun. This is what I want to do when I grow up. But later there were other boys. There were other things to get excited about, like social sciences and knitting socks and French. I studied French in school and philosophy and art. And I started to feel slowly that maybe the world of technology is a little bit boring and a little bit lonely, a little bit mathematical, and belongs to the smelly, introverted boys in the high school class that I was going to. And it took me almost 10 years of not working within technology to get excited about it again. And that happened when I was studying in Stanford University in 2009. And I took part in this product development course over there. And Stanford is surrounded by technology enthusiasts. There's Apple and HP and Facebook, and everyone lives and breathes technology. And I stumbled on this programming course. Was the Ruby on Rails for beginners or something like that. And when I wrote my first lines of Ruby code, I felt the same jolt of excitement that I felt as a 13-year-old. And I realized it wasn't Al Gore, it wasn't the teenage girl hormones, it was the coding that made me so excited. And I decided that, okay, I want to make other people really excited about this too. I moved back to Helsinki, and no one was excited about coding around me. I had absolutely no other female friends who would have been able to support me in my learning or talk about the things that I was excited about. So me and my best friend Karri Saarinen decided to do something about it, and we organized Rails Skills in one weekend. It was supposed to be a workshop for our close friends, never something that would spread. I probably would have thought about the name again if I knew that it would become a thing. So it was roughly 30, 20-something-year-old women getting their first experience in software craftsmanship. And we used Rails to build like a really quick, dirty application. Most of the participants didn't understand the computer science theoretical frameworks or the concepts that they were using, but they had fun and they created something that they could show to their colleagues on Monday. And they used the terminal and they run into acronyms that they didn't know before. And they got this experience. And then me and Karri got a call from Singapore. The event had started to spread on Twitter, and people had started to say that, oh wow, like cool things are happening, and that over there on the left-hand side is DHH, he's the founder of Ruby on Rails. And I was like, oh, like DHH knows that I exist, this is the single most best day in my life. And as said, we got a call from Singapore, and Jason Ong said that you guys should come to Singapore and do Hello Kitty Rails Girls workshop over here. And this is the first time in my life when I felt like Alice. We had absolutely no idea if the curriculum we had done was any good at all. It had been tested once at that point. We didn't have any funding for the project. We didn't have a project plan. But we were both students, and we had never been to Singapore, and we had student loan and a lot of free time. So we decided that, okay, whatever, why not? Let's do it. We flew to Singapore, and today Rails Girls has been organized in over 270 cities all around the world. Also, a few times here in Barcelona. Everywhere from Amman to Australia and Belo Horizonte to Berlin. It's local volunteers, local Ruby core members and Ruby developers who want to see a more diverse community. And this whole experience of going through Rails Skills and seeing how colorful and exciting and fun the developer community is led me to come up with my own mantra or thesis, and that went like this. If Ruby or JavaScript or Python is the next lingua franca, if our kids learn English, Chinese, and Ruby as their first foreign languages in school, the way we are teaching these things is very outdated. Instead of grammar classes, we should be teaching them poetry. And what I mean with that is the same way we teach English or Finnish to people. It's not only conjugating different verbs or learning the grammar patterns. We use and learn a language by using it, by writing really bad poems and essays and stories, and by reading classics and contemporary books, and by having improvisational theater plays and so forth. We learn a language by using it, and the same applies to non-natural languages like programming languages. So I was pretty sure at this point that, okay, this is going to be my mission in life. I want to write a book that shows all of the colorful and fun and whimsical stuff that I see in the world of technology. Because when I was learning to code, I had this little guide. Her name is Ruby. She's 6 years old, completely fearless and a little bit bossy. And every time I would run into a problem that I didn't understand or an acronym that I didn't quite get, like what is object-oriented programming or what is garbage collection, I would try to imagine this little girl, like 6 years old, explaining it in simple and understandable terms. And I think at that point something switched in my brain, and I started to, like some people see numbers as colors, I started to see the world of technology as stories. And all of a sudden it totally made sense that, like if Apple were a character, it would definitely be Snow Leopard, who's beautiful but doesn't want to play with the other kids because she only enjoys beautiful and nicely designed things. And if Linux was a character, it would be the penguin, who's really smart and efficient, but somewhat hard to understand. And if Google was a character, it would be the green robot, who's really friendly, but super messy at times and grows way too fast. And there's Django, who has a pet python, and Firefox, or the foxes, who are really idealistic and don't want to obey the rules, and so forth and so forth. And I told my mom about this book, and she was like, "Are you writing some sort of a Soviet children's book?" And that sounds really bothering that you're trying to explain this world of corporations that run our world and blah blah. And no, Mom, I'm writing a story about the forces and the companies and the value systems that surround us and our kids every day. But in addition, I want to introduce kids to the idea of computational thinking, namely the concepts that you should understand about code even before you write your first line of code, those thinking structures that apply across different programming languages. So, in my journey as a children's book author, there were 3 little problems. First of all, I wasn't a very good programmer. I didn't have a PhD in programming or in early childhood education. I didn't know how to draw, which is a bit of a hindrance if you want to be an illustrator. And I had never written a book before. But if anything, programming has taught me a lot of resilience and the idea that making mistakes is an incremental and important part of learning. And I figured that maybe, for instance, drawing, it's mechanical repetition, it's learning to control your hand. And if I draw 1,000 circles, eventually the circles will get better and I can do something more complicated. And these are some of the first illustrations I found from Ruby. You can see that they are not very good at that point. But I kept drawing and I kept obsessing over this idea. And it really helped that I had this global Rails girls community around me who started to imagine with me and gave me the support and belief that yes, I can actually do this. I can actually be a children's book author who writes about software. And I even got this plush toy from Belo Horizonte, and around this time I started to feel, maybe this is the thing. Maybe I have enough of these Ruby parents who I've met throughout the world who will be willing to support this thing. Even the pictures got better, and around this time I had moved back from New York to Helsinki, and I had a lot of free time in my hands, and I decided that what if I do a Kickstarter campaign? What if I put this on Kickstarter and ask for $10,000 to cover my self-publishing costs? And around this time I had the pictures, or a few pictures, and I had an idea, but that was that. And also around that time, Kickstarter in Finland was kind of illegal, so I was breaking a lot of rules by doing this project. So one afternoon in January, I put the project out there, and it was the best and the worst decision I've ever made. Because the project, instead of gathering $10,000, it ended up gathering $380,000 worth of pre-orders from 9,000 backers from all around the world. And my first reaction was to panic. I cried. They don't realize that I don't have the book. I have an idea, but I don't have the book. And this whole journey of making the book and the Kickstarter community and becoming a children's book author overnight has been one of the most stressful things in my life. The book was a year delayed. There were so many problems and things that I didn't anticipate. And honestly, if I knew how much work it was, I wouldn't do it again. But luckily, I didn't know. I was still an optimist around this time. I still am. And the book, I think this week actually, there's been a book on Kickstarter that talks about role models for little girls, and that has become the bigger, more successful Kickstarter project. So I should update this slide, but it's still one of the most backed kids book project out there, and it's also 20% of the annual entire book exports of my home country of Finland. And around this time I had no book in my hand, so a little bit of stress out there. So the second time I felt like Alice in my life. I felt like I was given the red pill and the blue pill, and I took the red pill, and I fell deep, deep inside of the computer, and ever since that moment I've been trying to find my way out. So a long introduction, but 4 very simple and small lessons that I've learned from this journey. First of them is to start with a hypothesis, and this is probably the most pure and beautiful advice any children's book has ever given me. Beginning at the beginning and go on till you come to the end, then stop. And you can apply to this any problem you have in life. Thank you, Lewis Carroll. So starting with the hypothesis. So what happens when you're a children's book author overnight and you become this like wildly successful role model all of a sudden, and this is what you have on your website or on the Kickstarter page. This was the first version of the workbook for Hello Ruby, and you can see there's some ideas like bug Sudoku and pixel art and my first error message. But those of you in the audience who are now like, I'm not sure what this has to do with programming, I absolutely agree with you. This has nothing to do with programming, and I'm ashamed that this still exists out there and anyone can find this, but this was the first version. And if there's anything I've learned in the past year, 2 years, is that you can't have a finished book with 120 pages and 14 different translations and blah, 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 unless you have the guts to put out the horrible, horrible first version out there. And one of the big quotes that kept me going, I'm not going to read the entire thing, is from Ira Glass, who was a podcast producer for This American Life, and he said that no one tells the creative people that all of us who do creative work, we get into it because we have good taste, but for the first couple of years you try to make stuff, it's just not that good. It's trying to be good, it has potential, but it's just not that good. And what he's talking about here is making those 1,000 circles and having the sort of persistency to keep working on your idea, and then also having the guts to put out that horrible first version to get the feedback. I think today little girls, they don't know that they are not supposed to like computers. I think little girls, they are very precise. They are awesome at asking questions like why and what if and how. They can concentrate well. They have amazing imaginations, and they don't know that they are not supposed to like computers. It's us parents who do. It's us parents who think that computer science is this weird, esoteric, scientific discipline full of mystery and acronyms, and to some extent they are right. There's an awful lot of this magic that is built around programming, whereas I try to explain to kids nowadays that programming is like text editing. It's editing a text and building a little universe with your own words and like managing the complexities and abstractions of that universe. And somehow we've come to the point where in school we do, like Sandra was saying, we do teach kids how the human body works, and we do teach kids how the combustion engine functions or how to become an astronaut. But the most simple questions the kids ask from us, like, Linda, what is a bubble sort algorithm? Or what actually happens when you press play on YouTube? Or is internet a place? Makes us very squirmish. Makes us say, oh, it's somewhat magic or very, very complicated, where in reality it's not. It just happened really, really fast, and we don't have the vocabulary or the pedagogy to teach these things yet. Wow. So second thing I've learned from being a children's book author is always asking the question, what? Being very curious about things. And I mentioned Ruby, and she's 6 years old and completely very, very bossy at times. And I have this nagging feeling that I'm creating the most obnoxious generation of kids out there, but I'll tell the story anyways. So when Ruby gets told to go to school, and her father tells her, Ruby, we're running late from school, dress up really quickly. She does dress up, but she leaves her pajamas on because Dad didn't specifically tell her to take the pajamas off. And when Ruby is told, clean up your room, Ruby, your toys are all over the place. She does clean up the toys, but she leaves the pens and papers on the floor because they are not really toys. And this is where the obnoxious kids come in, because they do learn about something very profound about how to speak to a computer, namely that you need to be very exact. You need to be giving commands in the right sequence, and you need to be very careful when you name things. And after having received some reader feedback from people, I met this little girl who now declines to answer her father's questions like, how was your day in kindergarten? Instead, she says, you need to give me a true or false statement, like, day in kindergarten was great, true or false. So in these kinds of ways we're affecting the way kids see the world. So in Ruby's world, programming is learned through play, and I came up with this sort of curriculum of code, like these basic concepts of programming that I think would be useful for any kid or any parent to understand even before they start to write Ruby or JavaScript or Python. And for example, the idea of repetition, the idea of computer being very good at repeating things if it's given specific instructions of what to loop is in Ruby's world taught through a dance party. So Ruby's favorite dance move is clap, clap, stomp, stomp, clap, clap, and jump. And we learn a for loop by repeating that 5 times. And we learn a while loop by repeating that while I'm standing on one leg. And we learn an until loop by repeating that until mom gets really, really frustrated. And we learn about decomposition, the idea that all of programming is really taking apart a big problem into smaller problems by solving Ruby's friends' problems here. So it seems like Android has forgotten one step in his flowchart, and the fox has done something in the wrong order, and there's something funky in Ruby's loop because she keeps on eating even though she's not hungry anymore, and so forth. And actually, funny story, the book was launched in Japan last week, and my Japanese publisher came to me and said, we have a problem, Linda. One of the steps is problematic here, because Japanese people don't wash in the what's it called, like the not sink, the washing tub, tub. They relax in the tub. They first wash themselves and then they go to the tub to relax. So we needed to change up the code here a little bit of localization. And then finally they learn about algorithms, which for an adult sound like a really big and scary word. But for kids they are like, wow, that's a great word, algorithm. And that algorithms are really like recipes. They are step-by-step instructions to solving a problem. And good recipes allow you to switch ingredients, like make banana muffins instead of blueberry muffins, or make muffins for 50 people, or cupcakes for 500 people if you vary the amount of ingredients. And most importantly, the most important things I want kids to understand is that even the biggest problems in the world are just tiny problems stuck together. Second to last, imagination powers all progress, and asking the question how. So if I was earlier bashing the idea that computer science education is boring and outdated, how should we then be teaching these things? And I think there's definitely 2 joys in programming. There's the more abstract, the more intellectual joy of writing a beautiful function, or abstracting properly like a part of a function into a new class. And that's amazing, and that's being educated. When I went to AP computer science class in high school, the first task was to write a program that calculates the square roots of the first 20 prime numbers. And that, for a girl who made an Al Gore website, was like, this is not as exciting. And then there's the second type of joy of programming, which is having a problem and going to Stack Overflow and copy and pasting like bits of code and figuring out like, oh, I'm not sure if this compiles, but let's try, and oh wow, I made this happen and it kind of works. And I think that's called play, and that's missing from the educational system. So I went to the people who understand play best in the world, namely Lego, and I spoke with them and asked, how do you define play? And they say there's physical play and play with objects and symbolic play and pretense and socio-dramatic play, and then there's games with rules. And for some reason, when we adults think about play, we only think about games with rules. And they also listed out different motivations of play. There's achievement-based motivation and social motivation and immersion motivation for play. But again, whenever we talk about education and gamification, we tend to work in this one column here. We talk about progress and power and accumulation and challenging others and optimization and stuff like that. Whereas in reality, everyone here who's ever programmed knows that there's so much other types of joy also. There's finding and giving support and collaboration and exploration and finding new ways of solving a problem, and at least for me, like the joy of avoiding real life problems. And around this time I realized that I want to be teaching the curriculum of code, the things that I showed you earlier, and this is how I want to be teaching these things, like using all the different aspects of play. So, final thought, you can only connect the dots looking backwards. I think one of the things I'm most jealous about for the people who lived in the 70s or 80s was the idea that for them technology was very sort of tangible. You could actually like take a transistor and see how it functioned. You had transistor radios, and for us, like at the end of a single pen there might be like 300 million transistors, like an intense and insane amount of technology that we don't understand anymore. And to sort of solve that problem, we started with this premise of showing kids these 4 pictures. There's a dog, and there's a toilet, and there's a car, and there's a grocery store. And I asked the roughly 6 to 9-year-old kids, which one of these do you think is a computer? And all of the kids, they shake their heads very seriously and say, are you stupid? None of this is a computer. A computer is the glowing box in front of which mom or dad spends way too much time. But then we talk and we figure out that, like maybe a dog is not a computer, but dog might have a collar that has a computer inside of it, and that might be useful if the dog is like prone to running out. And a car is not a computer, but car has a navigation system that kind of makes it into a computer. And in grocery stores, the machine that makes the ice cream stay cold, and the burglar alarms and the cashier machine, all sorts of computers. And in Japan, toilets are computers, and there's even hackers who hack them, and this always makes me the most popular person among the 6-year-olds in the room. And I tell them that in reality, all of you kids have roughly 100 computers at your homes, and that you guys are going to be the last generation of kids who remember the computer as a glowing box, because computers are not going to be defined by screens much longer. They are going to be implemented everywhere, so that your toothbrush is a computer and your teddy bear is a computer. And then we go one step further, and I give them these little stickers with an on-off button on them. And I tell them, kids, for this afternoon you have this amazing ability to make anything in this room into a computer. And again, the kids complain and say, oh, that's too hard, and that's too complicated, and I don't know the right answer for this. But I tell them, neither does your parent. They've maybe heard about the Internet of Things or IoT, but you kids are going to be the ones who grow up in this world where everything is a computer, and it's kind of up to you to design that world. And one of my favorite stories is this little girl who came to me with a bicycle lamp, and the first thing she suggested was that, Linda, if this bicycle lamp were a computer, it could change colors. And I go, that's a really awesome idea, but are you really using all of the aspects of computing that you could be doing? And she goes back to her place, and after a little while she comes back to me and says, Linda, if this bicycle lamp were a computer, we could go on a biking trip with my father, and then we could sleep in a tent, and this bicycle lamp could also be a movie projector. And that's the moment I'm looking for. Not the moment when the kid understands what hashes or arrays are in Ruby, not the moment when they write the perfect if-else statement in JavaScript, the moment when they understand 3 very profound and beautiful things that us adults have a hard time understanding. First of them being that the world is not ready yet. There's so many problems that we haven't solved in this world. Bicycle lamp movie projectors might not be the most important one of them, but that's still a problem that exists. Second of all, technology is an amazing way to make the world a better place because it scales, and you can create wealth around you, both economic but also social and sort of environmental wealth by making things more efficient and clean and better. And then finally, that they themselves can be a part of that change. And chances are that little girl will not be the next Steve Wozniak, but for a moment there she had the agency and self-belief that she could be the next bicycle lamp movie projector inventor. So it's very curious that the computers that surround us are getting more and more pervasive. And still the abstractions we use to talk about computers come from the year, I think, 1947 or something like that, when John von Neumann came up with the famous von Neumann machine. And when people ask, so what is a computer? If it's not the glowing box or if it's not defined by the screen, how do you define a computer? And I usually tell them that a computer is any machine where you put in data, something happens to the data, and the modified data comes out of the computer. And what makes computers so special is the memory. Because in the memory you can store two different kinds of things. You can store the data that comes in and the data that goes out, but you can also store the instructions on what to do with that data. And that's what we call programming, and it's the programmer who writes those instructions. And that makes a computer a magical machine, because it can be anything based on what kind of instructions you give for it. A pinball machine is a pinball machine, a tractor is a tractor, but a computer can be anything based on the instructions you give for it. And then we do this exercise with the kids where we build this computer out of cardboard, and one of the kids crawls in, and there's little code snippets like come out jumping on one leg, or come out crawling the other way around, or something like that. And the kid is the data that goes in, and there's the instructions, and then out comes the modified data, and then they go round and around and around until the computer eventually breaks. Very fast processor inside. I've also asked a bunch of times kids to draw what they imagine is inside of a computer, and this is really interesting. There's kids who definitely see computers as abstractions. They have this very adult way of seeing computers as connected components and networks and parts. Then there's my personal favorites, the gear gurus, the kids who somehow see computers as this steampunkish world of little gears interlocking and working inside of a computer. And then there's the surprisingly smart kids who understand that computers are based on logic, not magic. They understand that somehow electricity is involved in the game. They draw these like different components and connections, and I think these kids will have a very bright future. So then the kids build a computer out of paper, and they get to know the bossy CPU and the helpful RAM and the ROM that help it remember things, because the CPU, even though it's clever at bossing people around, it doesn't really remember things on its own. And they get to design their keyboards and work through problems of like what kind of memory is ROM and what kind of memory is RAM, and what does the GPU do, and then finally they get to design their first applications. And my favorite story is this little boy who came to me and showed his computer that he had built with his father, and his favorite thing in the world is to be an astronaut. Or actually the boy is the mission control man, and he has these like huge headphones on, and he's completely immersed in his tiny paper computer, because you see he's built an intergalactic planetary navigation application. And his father is the lone astronaut who's on the other side of the room, but really far, far, far away in the Martian atmosphere. And the little boy's role is to bring Dad back safely home to Earth. And I think those kids will have a profoundly different experience of what it is to work in technology and what kind of roles exist in this world. So I know I'm running out of time a little bit. The last thing I want to end with you is the idea that technology is progressed by imagination. And somehow we adults forget to use our imagination. And Lewis Carroll reminds us to think about as many as 6 impossible things before breakfast. And the roots of computers, they are in poetry and math. The world's first programmer was Ada Lovelace, who was a Victorian-era English woman who hanged out with Charles Babbage and those kinds. And her father was the poet Lord Byron, who had some womanizing characteristic. He had a lot of affairs and was this like weird Renaissance man. And Ada's mom obviously was really pissed off at Byron and said that my daughter will have a rigorous mathematical education. She will have nothing to do with that poet nonsense. But somehow Ada kept part of her father's genes, and when she grew up, she hanged out at the London like intellectual era of the time, and everyone was super pumped about the like difference or the analytical engine or the difference. The analytical engine, and people were really excited about this concept of a computer, because a computer used to be a human who would calculate different kinds of number series. So the same way as you would have a waitress or a doctor or like a nurse, you would have a computer whose role was to calculate different series of numbers, because you didn't have calculators, so you needed someone to do the math for you. And all of these gentlemen were really excited about the computing and calculating powers of computers, and they saw like a computer as a calculator. But Ada was the first person who understood that with numbers you can represent logic, and with logic you can represent anything in the world. And that's why we call her the first programmer. And in the same way, I think the history of computing is full of these interdisciplinary, imaginative, crazy people who've redefined over and over again what do computers do and how they work. And they are definitely not dull or only logical or mathematical or even bad smelling, so bad me when I was a little girl. If you haven't read, I'll share these slides later, but the Seymour Papert paper from 70s, 20 Things to Do with a Computer, is a personal favorite of mine. And Alan Kay, who used to work at the Xerox PARC, where Steve Jobs and Bill Gates stole all of their ideas, has basically described a hackable iPad already in the 70s. It's amazing, it has pictures and everything. And I'm not the only person who's doing work with stories and programming. The way I learned Ruby was Wise Poignant Guide to Ruby. It's this weird, nonsensical journey of two foxes that like bacon. There's Lorem Ipsum that is really excellent. Ruby Wizardry is also in fairy tale format, and computational fairy tales actually taught me a lot about algorithms and data structures that are like areas that I don't know that much about. Okay, finally, the more approachable we make the world of technology, the more diverse, the more colorful, and the better place and world we'll have. And I don't think I need to make this point. We all agree on the idea that technology becomes better by having more people, more different kinds of people solve problems with it. And I think to some extent every problem will be a computer problem. It doesn't diminish the role of the human in the equation, but I think humans and computers need to work together, and that's why we need different kinds of humans to be involved. And somehow it's us adults again who have the more limited mindset. I think when I asked a bunch of kids, like, what is technology and what is it used for and who uses it, this was my favorite answer from a 9-year-old girl who proudly stated that technology is electricity that loves. Is there a more Björk thing to say? Technology is electricity that loves. It is used to play. I use it to have a conversation with my mom. We use a WhatsApp application. And then the most important thing, people use this technology. And I think if a 9-year-old little girl can state this so clearly, I think we all can agree on it. I think I'm out of time, so I'll give the session for the next person, but I think we'll have kind of a QA afterwards, right? Maybe a little bit. Or I'll hang out here and answer any questions if you have them.
You can have it now.
Oh, yeah.
Questions?
I have a question actually.
Cool.
How do you imagine this type of education in a system way? Like
Yeah.
systemic education, of course, it differs amongst other countries.
Yeah.
It's totally different in Finland than
Yeah.
in the US.
I used to be very gung-ho about like, yes, let's put programming into the core curriculum and let's do it fast, and what are you waiting for, you stupid education people? But the more I've worked with different people, the more I've seen different educational systems, I realized that there is some value in the educational system having so much inertia, namely that we don't accidentally shift history in a really weird direction. And this is a bad example, but like Nazi Germany and sort of education is so important that it's actually good that 20-somethings can't sort of too fast change things around it. But that being said, I think it's very, very important that these things are implemented into the curriculum, but I think every nation needs to have that discussion among themselves and sort of figure out what works for them. And I speak a lot I was in Netherlands a few weeks ago, and they asked like, how should we implement coding? And it really depends on like what kind of kids you want to come out of the other end. There's no one blanket proof, like, okay, this is the way you should be doing. I think all of the non-profit activities and the voluntary and like sort of after-school activities pave way for these kinds of things and show the local community how to do these things. And if I give an example from Finland, where I come from and the education system I know best, it was 3 years ago decided that Finland is going to put computing into the core curriculum, starting from the age 7. And the reason we did it was because the Estonians did it first. And we have this lovely competing relationship with them. So like, no, we can't lose to the Estonians. Yeah, UK did it too. And the difference for UK and for Estonia, so it's implemented this fall. This fall comes the new curriculum in in Finland, and the way we're doing it is it's going to be implemented across curriculum. So meaning coding is going to be taught in math class, it's going to be taught in arts class, it's going to be taught in social sciences, and the only reason we can do it is because the Finnish teacher training system is so world class, and our teachers. They top all of the charts. They have a lot of autonomy over their classes. And if I were to tell that, hey, Italians do the same thing, and it would probably not work because they would have a different system. So that's why, even though I would love to see coding in the curriculum very fast in every single nation, I think it's important to start that discussion. And it starts by asking the questions of like what kind of kids we want to raise up and what are the values we want to build our educational systems around. Yes.
Do you ever feel like there's a contradiction with kids, where like on one hand, like they think really broad and they have all this imagination, but then when they go to actually write code, it's like all the minutiae, like syntax and all this kind of thing. Is there ever that contradiction that you see?
I try to, so yes, definitely. And a lot of parents come to me and say, oh, I understand coding. It's very sort of like making very clear little instructions in only one way, and only one way is like prohibited and so forth. And yes, it very much like loses the creativity in coding. What I then try to do is use Scratch or some like visual programming language that removes the syntax errors that so easily creep up. Like I still make tons of mistakes every time I write code because I don't do it on a regular basis, so I forget the semicolons and so forth. And the second thing is like have everyone solve the same problem at least once and show how different approaches kids can have. Because if there's like one programming problem, there's at least 5 or 6 ways of usually solving it, and then show that even though a computer can be a little bit of a dummy because it only accepts exact instructions, there's different ways of instructing it, and all of them are equally good. But yeah, that's the hard part about programming, that you need to go through a certain amount of repetition in order to be able to have the building blocks to actually be creative.
Congratulations, I think the program is wonderful. And I do have followed many years these different attempts to introduce coding into schools. One of the things that I'm always interested in and haven't seen, which maybe you're in a position to affect, is the ethics around the use of technology, accessibility for disabled, for the use of maybe displacing work that might have been done by a human, or the discussion of a few robotics. Does that ever come up with a 9-year-old?
Yes. So very short answer is we are actually doing, so this started as a book, and I feel like book is a very useful format because it's kind of like a campfire that can gather people around it, and people understand what a book is, but a book is not enough to explain all of the depth and width of programming and technology, and to that extent we're doing like a summer school now, 2 weeks, first 2 weeks of June, and I have 3 teachers working with me on the curriculum, and the idea is that we do phenomenon-based learning, so we would have a topic for each day like food or society or home or money or nature or recycling, and sort of try to look at how technology is changing those things, and can we teach, say, computational thinking through that topic. So for instance, the topic of recycling, can we first have a discussion about like how computers can help us recycle things, and what kind of like algorithms should the computers have in order to be able to recycle stuff. But then also more profound things like we have a day where we'll be talking about data. And there's this play, you guys know Tag Your It, like tag your it and then running around. So we have a version of that where the kids get little pieces of paper, like 5-6 different colored pieces of paper, where on each piece of paper they write a data point, like I'm a girl, I'm 5 years old, I live in Barcelona, and I like My Little Ponies. And then you put your little data points with clothespins on your clothes, like this. And then we unleash 3 kids that we've chosen, Google, Amazon, and Facebook, and their role is to run around and snatch as much data as they can from the other kids, and you lose when you lose all of your data. And as a result, we have this huge pile of little colored papers, and then the exercise continues so that we've printed out the New York Times or Helsingin Sanomat, which is the biggest daily of Finland, and we've blocked out a few titles, a few pictures, and a few advertisements. And the kids need to pick up a new persona from the pile of data and redesign the front page in a way that would make that person click certain links, say like a little boy who lives in Madrid and likes turtles and is 6 years old, and really like try to imagine what would make them enjoy that page. And then we have a discussion about the ethics of all of that. Like, is it a good thing that more and more of the content we see is programmatically chosen for us? What might be good about that? What might be bad about that? And it's really, really intense and weird to have these discussions with the kids, but even more intense to have them with the parents, because these kids were at our offices and my mom came to pick one of them up, is my goddaughter, and she was like asking, oh, what were you doing? And then she goes like, oh, so that's how Facebook knows that I like that exact Zalando dress. And she had no idea of the powers and forces that were like happening underneath the surface without her knowing it. So definitely we're trying to figure out how to teach the ethics and that side of things. Artificial intelligence is something that I'm really like pumped about and excited to start to learn more about. I have this like gazillion-mile long answer, sorry about that. Next answer is short. Yes.
And where do you see yourself next?
I don't know if it's the same in Spain, but in Finland you're supposed to have a very sort of linear career. So you first start as a junior assistant, and then you become an assistant, then a project coordinator, and blah, blah, blah. And people oftentimes ask, so what is the next step? And some ways I feel like the modern time, the thing that technology gives us is the reach, and that I can be here in Barcelona having this discussion with all of you, and the ability to have like many different lives. And life is so short that I want to be doing many, many different things. So I want to be an illustrator and an author and a programmer. And I was once at this conference where they asked the same question, and I tried to think of the craziest answer I could give. And I'm like, I want to be a kindergarten teacher in Japan. And the audience laughs. And then 2 weeks after that, the Finnish embassy in Tokyo calls me and asks, were you serious? And I'm like, okay, yeah, sure. And I speak absolutely no Japanese. I knew kawaii, sugoi, and subarashi, which is like cute and awesome and great. And a year ago in February, I went for the first time in Japan, and I met a lot of people. I met with 2 kindergartens over there, and I like had discussions with them, and I absolutely fell in love with Japan. I returned 5 times in the last year, and actually the book was launched in Japan last week, and it's the 4th most sold book in the entire Amazon and Rakuten of Japan right now. And again, it's one of those things where like none of that would have happened unless I had opened my mouth and said the like kindergarten teacher in Japan thing out loud. And I think that's what I plan on doing in the future, like saying out aloud things that I would maybe want to do at some point, and hoping that life and serendipity and everything will take me there. Yeah.
We have to stop questions, sorry. But you can talk to Linda later.
Yes.
We still have networking and drinks after the event. Perfect. I hope you can stay. Now Bernat is our next speaker.
I'm going to present him. So I'm very happy Bernat is here because many of our friends at Schibsted are part of CodeLearn too. And they are doing a great job teaching kids how to code or how to use technology. And they have 9 schools already in only 3 years. So kudos to these guys. And let's go to the presentations.
Okay. He did that photo. Click. Okay. Yeah. Whoops. Well, hello. How are you? Good afternoon. I'm here to talk about CodeLearn. And I'm here to talk about cats. Awesome cats. No, sorry, wrong slide. I'm here to talk about human kittens, about education, right? That's why we are here. And I think that if we are here, it's because we all have all this common interest about education and about what's the purpose of education. Is it to create the citizens of the future? Yeah, probably. Is it to prepare our children to, sorry, is it to prepare our children for the age when they are, well, they have to work? Is it to prepare them so that they are ready to create the future of our society? Yes, probably. But if that's the case, our opinion is that we are not doing it very well. Why is that? Well, it's because, as I assume that most of us are engineers or have something to do with engineering, we know that tech is probably a very big part of our future, right? But unfortunately, we are not teaching a lot of tech to our kids. And that is what we see when the parents come to our centers, and they usually, I'm not sure it works, okay. And they usually ask this question, which is a pretty pertinent question. What do you do here exactly? And to answer this, we can use our logo. This is tricky, okay.
Yeah, the computer's behind the top.
Okay. No, it's okay. To our logo, okay, we are called CodeLearn, which is pretty self-explanatory, but I want to focus on this part, the computational thinking part. I'm sure most of you have heard about it, but what exactly is computational thinking? Computational thinking is a set of attributes that allows us to formulate a problem and its solutions in a way that machines can solve this, okay? This is a pretty Wikipedian explanation, and actually, if we go more to detail, it's a set of attributes, okay? Decomposition, pattern recognition, abstraction, algorithm. I'm pretty sure if you code, that you know these things and what they are. And that's because computational thinking has a very interesting thing, and the thing is that you learn it while programming. Let me underline it because it's very interesting. If I can, okay. Yes, you learn it while programming. That's why if you code, you already know that. But the most cool thing about computational thinking is that it helps anywhere. So if you are a lawyer, if you are a doctor, if you are an architect, but a house architect, is it useful as well? And I'm pretty sure that you can now understand that, okay, that's why when I go into an office, when I go to a shop, and I see the processes, how they do things, I realized that I could improve that. Yes, it's because of that. It's because you realize some patterns, you recognize some problems that you have solved before. And let me repeat that you learn it while programming. And once you have it, then it's like a magic tool. You can use it for everything. It's like a Swiss Army knife for real life. And because it's important, let me underline it again, that you learn it while programming. So, if there is this magical thing, this very good thing, that is computational thinking, and I'm pretty sure that most of us will agree that, okay, if it's that good, we want it ourselves and we want it for our kids. So, what can we do to learn it? Okay, learn to code, right? It was what we underlined before. I'm going to skip this one because I'm pretty sure at this point you know how important it's learning to code. But what I want to say, what I do want to say is that in 1841, there was the first study in Spain about literacy rates. And in this study, they found that 9% of the population could read and write. And what's interesting is that at that point, that 9% meant that 17% of men could read and write, and 2% of women could read and write. So it seems like we keep repeating the same mistakes in a way. The next question that parents usually have, once they somewhat know what we do, is, okay, so when should they start to learn? And the answer, of course, is as soon as possible. If we want them to have this awesome capability, of course we want them to start as soon as possible, because you know that theory, or it's not a theory maybe, that says that to be expert at something, you have to have 10,000 experience hours, right? Which is more or less 10 years. So if they start at a very early age, they will become adults having this totally assimilated and integrated. And because an image is worth 1,000 words, I thought that to teach you the how we teach kids these abilities, we can have some pictures, right? As you can see, we do all kinds of different stuff. We don't have like a teacher sitting and talking for 60 hours. It's very different. And we do all kinds of robotics, Arduinos, and of course programming. I think you get the idea. Yeah. And a very important takeaway from all this is that having fun is key. Okay, we of course have had an idea about this when we started, but we verified it. Hey, it's very important that the kids have fun. If they have fun, they will come back. If they come back, they will have more hours of expertise, and they will keep growing, and they will keep learning. And how do we do this? We do it through gamification, but of course, it's more important to have mentors or teachers and friends there that can help them to learn this kind of things. Because you could throw the best Minecraft party in your center, but if the kid doesn't trust the teacher or doesn't have friends there, it's going to be difficult that they come, or if they come, it's going to be difficult that they come back. We also have an online platform, and as you can see, it's kind of a game with badges, with attributes, items. And we teach all kinds of language, like Logo, like Python, Scratch. Too fast. The thing is that we also know that some kids prefer some languages and some others another ones. For example, Scratch is very popular within certain profiles because maybe it's more visual, maybe it's more creative, and other people, maybe with more mathematical mind, prefer this kind of languages like Python. And to finish, I want to talk about 3 challenges that we find. The first one is about perception, right? How do programmers see themselves? If you take a look at the job offers that you can find in the different companies, you will find descriptions looking for, hey, we are looking for a ninja, or we are looking for a superhero, or a rock star, blah, blah. But how do really society see programmers? Like standard nerds, right? So this is still a problem. And for example, I can remember a conversation with a mother that was coming to sing up his son. He's saying, yeah, it's his thing because he's always all the day in front of the computer. He loves to play. He will love it. And in the conversation, I learned that he also had a daughter. And I say, why doesn't the sister also come? No, she's a girl. She's not interested in computers. Yeah, okay, but she could try, right? So in the end, we convinced them to try it, and now that girl that didn't like computers is the best student in Kotlin. Not just the best girl student, no, it's the best student. So that means that a lot of people still have these bad perceptions about this profession that can affect a lot to the future of their children. As we can see, I don't know if you have seen this before, in the row that displays how developers are seen, you cannot find a rock star, right? It's a pretty bad perception. So that's something we have to improve. Also, we were talking about how you are never too young to change the world. That's true. But is this something that the parents know? Actually not. There is a Google survey that they researched the parents in Spain. It was released last month, and I think that the results were that 0.4% of the parents know what programming is. So it's almost nobody, no? Maybe the people that are in here. So we have to increase awareness. And we know that there are very good initiatives on the world. The United Kingdom made a very smart thing, I think, that is changing the name. As in most countries, they had a subject in the school that it was IT, right? And they were teaching the kids how to use Word, how to use PowerPoint, this kind of stuff. And they realized that if they just introduced Scratch, for example, the teachers would be like, okay, so now we have to teach Word, PowerPoint, and Scratch. But that's not the idea. The idea is to learn computer science, which is a different set of things. So what they did is start by changing the name, and that set the frame, right? Set the window saying, okay, this is a very different thing. We have to start learning these things because we are not going to continue with the old things that we were teaching. Also, they have a very good curriculum. There's also the Code.org initiative, where all the big software companies in the United States are behind, trying to say, okay, it's very important to code. There's Obama saying in the Christmas message, hey kids, don't ask for a video game. Ask your parents so that you can learn how to create your own video games. So the United States, for example, is very involved. Actually, it's one in 4 schools already have programming as a compulsory subject. Japan, this same week, they decided that they are going to add programming as also a compulsory subject. It's a worldwide trend, but here it's still a bit invisible. And about the gender gap, I'm not going to say a lot because in the next talk, I think they are going to do it. But we can provide the stats in our schools. This is the reality, just 12% of girls. Obama is sad. But well, it's improving. And we can see it ourselves. For example, the first year that we opened a school. No. The first year that we opened a school, it's very typical that the parents decide on September which after school activities are going to do the kids. And that's what happened. And on September, we had some kids singing up, and then during the year, it was like nobody came. And the next year, and now this year, this is very different. We have new people coming in every month and saying, hey, I heard the last day on TV there was a discussion about these topics, and I came here a year ago, and you told me about computational thinking and programming and these very weird things. But you know what? Last day on TV they said the same. So now I'm coming because now I believe it. So it's a matter of time, as a lot of things, but we are sure that Obama will be happy again. So as a conclusion, we know that children are the future is tech. So the only possible conclusion is that children are tech. Well, let me try again. Children are the future. I think we can agree. The future is in tech. Okay, so let's get children in tech. Thank you very much.
Because we're a bit short on time, I'm going to ask you to ask all the questions later while we're having drinks and eating, and it's going to be nicer. So now let me introduce Girls in Lab. I think they're doing a great work. I wish there was a group like this when I was growing up, because like Linda, I don't have many friends who are also into tech, and it's really nice when you are a girl and you get to meet other girls interested. So anyway, I'll give you the microphone.
Okay, hello, I'm Dania, this is Jimena, and we are here in representation of Girls in Lab. We are a non-profit cooperative that looks to back up young girls in their interest in STEM fields and technology in concrete. Now, ¿dónde está? Okay. Now you might ask why girls and why technology. This piece of data explains it quite well. The amount of women who are pursuing computing studies is not following what would have been the natural tendency. So instead of increasing, it has plummeted by a half in the last 30 years. So if we take a look at how this affects the job market, we can see that. We can see that the proportion between men and women in the ICT sector is far from balanced. So women comprise 30% and 18% of the ICT workforce in Europe and in Spain, respectively. And that's because women are not only less likely to enter a tech-intensive industry, they are also more likely to drop once they join. Now, what about the quality of the jobs? Well, women occupy a little bit less of an eighth of the management positions in the ICT sector. Even though they might have the same education, the same studies as their male counterparts, they tend to start in an entry-level position and that they get paid less. So that brings us to our next point, which is the gender pay gap. Now, it doesn't look that big at first, but yeah, it's women make 94.6 cents for each dollar a man makes. However, at the end of the year, that's $2,140 less. And that's only management positions. If we go lower, the difference increases. For example, a female programmer might earn 30% less than their male counterparts. Okay, so what's up with all of this? Does this mean that women are not into tech? Well, truth is that girls do like science, they do. However, as they grow older, their interest seems to decrease, or at least is not solid enough for them to pursue STEM careers. So that explains why, even though women are getting more bachelor's degrees, the rates in technical careers, such as engineering, are not encouraging. The reason for that, well, the way we are introducing technology in the academic curriculum does not help, and that's a problem for all genders, obviously. We are using tech innovations to aid a classical way of teaching. So, for example, we are changing a paper textbook for an electronic textbook. And we are not using technology for what it could be good, which is making students active learners instead of passive recipients. We could be using programming, for example, for them to train their problem-solving abilities, but we are not. There are also a lot of myths surrounding technology. As they grow older, the girls lose their confidence in their abilities, maybe because their perception of such abilities is tainted by old phrasings like girls are not as good as boys at maths, or engineering careers are better suited for males. And also, the products that are specifically targeted to them might be subtly saying to them that they are better suited for another field. To get extreme, we could put the pink kitchen set versus the Lego. Finally, there's not enough reference. The visibility women and their achievements are given is deficient at best. For example, last March, Microsoft launched a campaign called Make What's Next, and they asked a bunch of middle schoolers who want to be scientists to name a few inventors. And they easily came up with Einstein, Edison, Tesla, Graham Bell, Da Vinci. But when they were specifically asked for a female name, well, they simply draw blank.
My turn. I can't. Sorry about my bad English. That's why I need my notes. I'm so sorry. ¿Tú me pasas? The big trouble comes because there's a deficit on qualified workers in the sector, which will only increase in the future if we don't break this gap and do something. So, what is going... Okay, next one. Dale. So, what is going to be useful in the future? We must understand that science and technology are transversal disciplines, and we must train our future generation in a more flexible way. So what we do? What we, Girls in Lab, aim to do is to help gender parity by tearing apart myths and stereotypes and getting girls in touch with technology. We want them to explore the possibilities of technology and also to meet women that are making the changes. To do so, we are focused on 3 areas that they are called inspiration, development, and talent.
and it's a logical progression, really. First of all, in the first phase, we help them discover technology in hackathons, so they can have a taste of different inventions. In the development, we give them a space to practice and put their knowledge to good use in the campuses. And finally, we help them to meet people and make contact with females. The one thing that is very important for us is to keep our business model for free. We want to help every girl, but we are helping the girls without charging them anything. And to understand a little bit better what we are doing, let's see a video of our hackathons.
Nos han explicado cómo funciona una impresora 3D. Era como una máquina así, ¿vale? Que iba haciendo cosas así, rayitas. Hemos mirado con unas gafas de realidad aumentada. Veía una sala donde habían fotos que habíamos hecho.
Y hacías un juego solo con la mente.
Es muy chulo, se ve... Sí, me ha gustado mucho.
¡Estáis invitadas!
So, this is the end. Check under your chair and look if you have this, let's say, message there, so we can give you a book from Linda Lucas. I think these chairs here, maybe. Yo creo que están por aquí. No one? I think that crazy guy there hides them. But where did you put them? You don't know? No, but they are there. Yeah. Check it harder, yeah. Yeah. Stephen, under your hair. You have one. It should be 4.